I have some vector arithmetic set up here that I wanted to look at both algebraically and graphically. So first I have 3 times the vector u, which is a vector whose entries are 1 and 2. So this is scalar multiplication here. We're multiplying the scalar 3 times the vector u. And to do that, you just multiply each entry by 3. So let's see if I can get this writing tool to work. So 3 times 1 is 3, and 3 times 2 is 6. So the vector 3, 6 is 3u. And I'm going to go ahead and compute b here algebraically. So negative 2 times the vector v would be negative 2 times 4, negative 4, so positive 8. And negative 2 times 1, so negative 2 here. I want to pause and look at those vectors graphically. So, let's see, u is the vector 1, 2. So it's this vector here that's drawn from the origin pointing to the point at coordinates 1, 2. So here's our vector u. Now if I sketch 3u, that would be a vector from the origin to the point 3, 6. So here's 3, 6. It would be here. And I'll go ahead and draw that here. Okay, so there's 3u. Notice that 3u is just, look at this little arrow here, and then it's as if you repeated it 3 times. This diagonal line here is representing the direction of u, and so if we placed that same vector kind of 3 times in a row, we would generate this red vector here. Now looking at the negative 2v vector, so that would be a vector pointing from the origin to the point at 8, negative 2, so it would point right here. So it's going to be this vector right here. Now again, I've got parallel lines here going through, here's the vector v, and so let me go ahead and draw it. Oops. So this is the vector negative 2v. And notice that it points in the opposite direction of v. And it's kind of, if you lined up 2 of them, notice, I mean, the units are kind of drawn here with the diagonal lines. Now combining 2 vectors. So the v minus u, so I've gone ahead and copied them here. And now if we combine, so in the first entry, we would have negative 4 minus 1, so negative 5, and then 1 minus 2, so negative 1. So v minus u is the vector negative 5, negative 1. So that I would draw as a vector from the origin to the point negative 5, negative 1, right here. And let me go ahead and draw that. There's negative 5, negative 1. Notice that another way to look at this vector is if we followed, let's see, this is v minus u. So if we followed the vector v here, and then imagine the vector u here drawn over here, but it's negative u, so it would go in the opposite direction. So v and then negative u gives us that head to tail addition. That's another way to look at it. It's the path. If we follow the path v negative u, this is our starting point, this is our ending point. So this is the resulting vector. Okay, one last computation here. So the 3u minus 2v I've set up down here. I went ahead and 3u we already computed in part A, so I went ahead and copied that down. Minus, this is 2 times the vector v, so negative 8, 2. And now to perform the subtraction, we just subtract the corresponding components. So 3 minus negative 8, that's positive 11. And then 6 minus 2, that's 4. So the resulting vector is 11, 4. If I draw that, so 11 is way over here, and then 4 is here. So it would be this vector pointing here. Let me draw that there. Now notice again, I just want to trace the path. if we had considered this more as a path, so 3u, we drew that first, and then negative 2v, but instead of placing it extending from the origin, if we extended from where we left off here with the 3u, then that would take us from the starting point here to the ending point here.